Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of PG Mustard, and this is my co-host Nikolai, founder of Postgres AI. Hey Nikolai, what are we talking about today?
Hot updates, hot updates. Let's discuss this first.
Heap only tuple tuple. We're at that point again. Heap only tuple updates.
So let's start from small stories. So short story. First time I was in the US, it was 2008. I came for the conference in Maryland, and I was in New York. First time I entered to Starbucks, and they asked me what I want. I say a coffee, like cappuccino or something. They ask me, it should be hot or cold, and I say hot. And they give me, of course, cold, because they hear, the American pronunciation is hot, not hot.
So hot.
And if you say hot, they can hear cold, actually, because it's oh. So, okay, hot updates or hot updates.
Who serves cold cappuccinos? Wow.
Yeah,
anyway.
it's you should live here for a while to understand.
Yeah, I wish I lived in a climate where that was a reasonable thing to do. But yeah, so what are these? I guess this is a listener question and topic suggestion. So thank you to Andy for this one. The question was effectively, when should I think about tuning fill factor? What kind of
for tables,
kind of workloads?
For
for tables, I guess, but he actually didn't specify. But yeah, it's the because he asked about hot updates, I'm assuming tables, and what kind of workloads would it be worth customizing for? So yeah, really good question. And to answer it, we kind of really have to dive into what heap only tuple updates are, how they help, the advantages, that kind of thing.
Right, and this is one of the questions which are originally closer to infrastructure level, like DBA, DBRE, but I see it clearly that developers should learn it as well and understand it better, because like this is one of like administrative topics which are very beneficial to learn for developers, for people who write SQL, not just maintain Postgres nodes, because this depending on which indexes you define and how you write your queries, you can benefit from hot updates from having, or you can avoid it, right? So of course I wish we had all updates hot, but it's not possible, of course. And of course fill factor by default is 100. So for tables we should probably should start from basics, right? What fill factor is and how updates are happening according to Postgres MVCC model.
Yeah, let's start with how updates happen without this optimization. So before version 8.3, before your 2008 story, actually, it was around about that same time that this got added. All updates.
8.3, you say, right?
Yes.
The same version which got XML data type and functions. I remember it very well.
Oh, wow. So, of course, your one. So same version, and that means there were times before this optimization. So and of course we have regular updates or cold updates. I've seen them called at least once. So by default, Postgres, because due to MVCC and I guess other design decisions, will create a new tuple for each. Like if you do an update on a row, you'll get a new tuple, and you'll have an old one that gets marked eventually as dead and cleaned up once no transactions can see it anymore. And the optimization
by vacuum, it's cleaned later asynchronously, so independently by our activities, right?
Yeah, exactly. So the main optimization here, and there are some caveats, is that we can, if there's enough space on the page with the
which
original
is 8 kilobytes by default, and usually it's so.
Yeah, total size of the page is 8 kilobytes, and total amount left free is generally 0. So Postgres would try and pack these pages as much as it can by default. That's the fill factor we were talking about briefly. So by default, you have 100% or 100 as the default fill factor, so it won't leave space in them. Yeah, exactly, for tables. Yeah,
because for indexes it's 90. Okay.
Yeah, or B tree. Yeah, exactly. So this optimization, with some caveats, will try and update a row a row on the same page. So the new tuple ends up on the same page as the old one and tidies it up like without needing a vacuum, is my understanding. So the main caveat is there needs to be enough space on the page, and the other one is that it needs to be updating columns that are not indexed in any way.
Right, and here is very important. Two conditions should be met. You're absolutely right. Enough space in page, and we are. By the way, we are skipping discussing toast here. We assume if we insert value which exceeds page, it's shrinked, and toast tables are used and shrink to like 2 KB, also compressed. But we skip it here. But of course, the space should be there inside our page. And a second condition says, you said indexed columns, but indexed should be defined explicitly. What does it mean, indexed? Of course, if you create index on some column, this means this column is indexed. Okay, but what if you use a column inside where clause, meaning you create a partial index?
Yeah, partial or expression indexes count too, I believe.
Right. So if column is not used in any indexes inside like the main body of definition, or including covering indexes, right? But it's used only inside where clause, it's also counted as like being used. And if you update such column, you cannot have hot updates, unfortunately. And the very popular example here is having a column called, for example, modified at.
Yeah.
And you just modify time, and that's it. And then you say, I want to index only part of my table where modification happened only recently, and that's it. You put like create some index blah 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 where modified at is in this year only, for example, and that's it. If you try to modify modified at column updated, you don't have hot updates, never. So like it's not possible. Or I mean, any update will modify this column, because modify that usually updated by some trigger or by application itself. But any update is supposed to insert new value inside this column, meaning you will always be touching a column which is participating in some index definition. So you will never have hot updates. I have an article about it. So about this. Because I've hit it in production. I thought I'm optimizing things, but I lost hot updates completely, and it was not good in terms of performance. Actually, question: why? These two conditions are met, but why do we want it? Right?
Yeah, that's a really good point.
What's the benefit?
So, my understanding is the without this optimization, update-heavy workloads become very difficult on Postgres. So we get what's famously called write amplification. The Uber blog post is like the most extreme, I think, example I've seen of this in the wild. But if we have actually, there's a really good Adyen blog post on this more recently as well. But the way they explained it, I thought was really neat, which is if we have a single row that has, let's say, 10 indexed columns, doing a single update to that row requires us to not just write to a new page in the heap in the table, but also to update 10 index pages too. So for one update, we have 11 updates, even if that update doesn't update an index column. So even if those are effectively unnecessary updates. Whereas with this optimization, if we are updating a single column that's not involved in any of those 10 indexes, we can get away with a single page write instead of 11. And that's a huge benefit, obviously.
Right. So, all Postgres indexes are direct, unlike in some other database systems where sometimes there is discussion, should we have indirect indexes as well? These discussions pop up periodically, and probably we should. For example, in some design could be only primary keys indexes which support primary keys are direct, meaning that they point to heap, and other indexes could point to primary keys. And in this case, we would not need to update all of them, but currently in Postgres, all indexes point to heap. They say this page and some offset. And if an index doesn't have visibility information, this is the key also to understand it. So visibility means which is this tuple dead or still alive for our transaction. And it means that index should you need to consult with heap to understand it. And this means that if some tuple is dead, indexes also we forgot to say in VCC in Postgres basics of it. Any update means some tuple. You actually described it. A tuple is deleted and new tuple is created. A tuple is a raw version, physical raw version, and since index doesn't know which is live, it needs to have both old one and new one, because old one probably is still needed for some transactions. And so, right, if we have 10 indexes, we need to create to change all of them, and later auto vacuum or regular manual vacuum will need to clean up all of them, all that entries there. And also page split can happen, affecting performance even more if some index and B3 index already don't have space in some page. Although fill factor for indexes and B3 indexes is 90, so some space should be there. But if not, a new page needs to be created. Split happens, it's penalty for performance. Right. So
there's a few, while we're on the advantages or the benefits of this, there's a few others that I know we've covered in other episodes briefly, but as well as not needing to update the indexes, as well as less bloat in the indexes as a result, there's also potential for less bloat in the table long term.
Right.
There's less write-ahead log generation. Normally, I believe it would normally be faster. The correlated data stays correlated. So when we were talking about Brin indexes, for example, so there's a bunch of other. Oh yeah, also I think reduced vacuum overhead. Because some of this is being tidied up.
Right. Let's don't touch additional in-page vacuum, which happens on the fly here. But it's too much details. Usually DB is usually more. Let's focus on performance for developers. So right, hot updates usually are much better, meaning that your actual update is much lighter. So if you check, explain, and analyze buffers, you will see that your update modified much fewer buffers, right? Made them dirty or written. And this is great. And of course, here in this topic, we should not use only micro analysis. We need to check many of update cases. So it makes sense to generate some benchmark and take your data, simulate your workload and see how many updates are hot. It's easy to you just need to inspect pgstat user tables. It has both update number of tuples updated and number of tuples updated in hot manner, and updated includes hot, of course. So it's you cannot summarize them. One includes the other. And the ratio is easy to get, and the closer to 100 you are, the better performance will be, because again, buffers rule works here as well, right? The fewer buffers will be touched because fewer indexes need to be adjusted.
And that's a really good point, actually. It's possible that you're already, even without doing any tuning, you might already be achieving close to 100% hot updates. So there might be, there might be no need to change your settings. Equally, in that situation, you need to be very aware of that, because if you do anything to prevent hot updates, like you mentioned briefly earlier, if you add an index,
it was a Ruby application. Very interesting, very good startup acquired by a large company later in San Francisco. And I was advising them, and I said, "Oh, here we we can reduce our index size and its scope, just making it partial. Let's do it. We will put this column to where clause index is much smaller, faster. Great. By the way, also worth pointing that if we have a partial index, if its scope in terms of how many rows is out of our change, so I mean change is happening outside, this index doesn't need to be touched, of course. So
Yes.
if one of our 10 indexes is saying like it's indexed only this part of table, but we change another part of table, of course this index doesn't need to be changed. But in my case, I speeded up my query, but then we deployed it, and then I suddenly see that hot updates. I was checking pgstat user tables and gathering statistics, showing that we're good, we have so many hot updates, and then suddenly, after release, it dropped, like to zero, basically. And I what's happening? And then I realized. So I explained this case in my article. Actually, this is quite a bright case which says that our changes should be tested at various angles, not only for our workload, but questions should be, will other parts of our workload be affected? And I didn't see so far comprehensive testing, like testing whole workload every time. It's quite big and expensive task, but still there are some ideas, and in some cases we achieved. I mean, I've built some systems which are close, or it's easier, like you need press a button and have this kind of testing, but it's another topic, of course. So so
in terms of what developers can do, I guess being aware of what their current state is a really good starting point. So checking that view for highly updated tables and just getting a sense of what's the current proportion of updates that are hot is a great starting point. If it's 0, you might have room for a lot of improvement. If it's 100, you might need to be very careful. But anything in between, there might be room, I guess, for a bit of optimization.
Right. Having good monitoring, which observes all tables and pgstat user tables and observes that it helps. But also, you of course, having a regular update, it doesn't hurt originally. Like it's okay to have it, right? But if you expect that this table write performance matters a lot, and also data volumes are huge and data grows, so pressure on vacuum will be high. A lot of work to delete these dead entries both in heap and all indexes, right? Of course, it makes sense to try to achieve a higher ratio for hot updates, right?
Yeah. I guess the bigger your workload, the more this percentage improvement will help you.
Question to you, actually, as an expert in explaining plans and so on. Do you think having auto-explain running with buffers options enabled for slow queries can help to identify issues? For example, we have updated which was slow. We see it in auto-explain log, and we see a lot of buffers involved. We know that we update just one row, but why so many buffers? Meaning that maybe many indexes were involved. Of course, maybe this update includes select subquery. So that's why we try to find which row we want to update. This is another reason for. But this would mean that buffers are in red. I mean, hit and red, right? But if we see a lot of buffers dirted and written, also might be related to hint bit, updating hint bits, a different story. But do you think it's a sign? Like we see a big number, so probably we should try to understand what's happening with hot update ratio.
Yeah, exactly. I think that's the kind of thing where you can spot that there is an issue, but you can't necessarily tell what the issue is, and this would be a very big sign of it. Like even in select queries, we in our tool try and point out when we think there's a disproportionate number of blocks, even shared blocks red written, like the hit or red, versus the amount of data being returned, because that's normally a sign of bloat, but it can be a sign of other issues as well. So it's
right.
it's one of those ones where a high number of blocks might mean you've got a low hot update proportion, but it could be a sign of other things. So yeah, definitely feels like the kind of thing where you could point out there's a problem and suggest some things to look into for sure.
Right. So checking pgstat user tables. This is number one thing here. Okay, good. And if we, for example, achieve high number, we should like keep watching, right? That's it.
Yeah, monitoring again, isn't it? In terms of what people can expect in terms of speed ups or in terms of like reduction in some of these numbers, I think the AdGen blog post I read was the best like real case I saw. So they reduced was it write ahead log they had a serious amount of write ahead log generation, but they reduced it by about 20% or so. That feels like an interesting number to me. So
Right.
I don't think people should expect 10x improvements in some of these things.
This is a very good point. So it's not only about timing of your update, but also you generate a lot of wall data, and means that you put additional pressure to your backup system and also to replication system. So more bytes should be transferred to standby nodes, both physical and logical. So it's like a lot of work. And having Postgres 13 or later helps here, because in pgstat statements and in explain analyze, you will see wall metrics, how many bytes and how many full page inserts happened and so on. This is great point. Also, actually, you mentioned this earlier. Having Postgres 13 or 14 or maybe 15 helps as well, because B3 will be more compact, right? In this case, how is it related to hot updates? We have even updates became not hot. We have a smaller penalty in terms of maintaining index state, right?
There's a good video by Lucas Vittel on this that came out around about that time. That
it's about let's delete from. It was originally a Percona blog post, I guess.
Okay, great.
Right. Let's delete from the end or something like this, right? Or
it was something about, I think the video
bottom
might
up.
have been titled Bottom Up Indexed. Yeah, exactly.
Right, because if you start from the end, we will have empty pages or something. I may be wrong. Let's not guess. Let's just provide some link and read about it later again. Right. Yeah. Actually, you mentioned Lucas Fittel YouTube channel, PGAnalyze YouTube channel.
Yeah.
I think it's underestimated, because I would warn our audience, because it's too deep. It's like
It's very good.
Yeah, you should go there if you're already not a new user of Postgres. But once you already know basics, it's super cool channel, because it's very deep. It's very interesting. I learn a lot every time I open it, so it's good.
Yeah, okay. And short videos as well, like 5 minutes.
Right. Reverting us to the very beginning, I should point to the fact that if you want to learn about hot updates, previously I always said you cannot find it in documentation, because documentation didn't have anything about it. Now it has, since Postgres 15 or 14, 15, right? But it has only a small page. It will not be enough for you. I mean, even if you're just starting, if you want to understand how updates are working, I encourage everyone to open source code again and find README related to hot updates. Much more interesting information there. But of course,
very in-depth
maybe too
again.
deep as well. Say again?
Yep. Very in depth, I was going to say, but it's quite beginner friendly. Like I looked at it earlier today, and there's a glossary even of kind of definitions,
it's like
even
whole
within the
project.
README. Yeah, it's great.
Yeah.
So yes, I'll include links to both of those. There's also one final kind of place that people could look into if you want diagrams, or you're quite a visual learner. There's a good part of the guide by, we've mentioned it before, by Hironobu Suzuki.
Internals.
Exactly, the internals book. It has the online version I can link to with diagrams of how this works.
Yeah, and Yegor Igor Rogov's book also has this topic covered, also internals worth mentioning. Well, okay, good. And finally, related to hot updates, I have a feeling that a lot of things can be improved here, definitely. For example, there was this discussion of the idea of partial hot updates. So let's have some indexes are updated in regular way, some in partial if it's possible. But as I know, it was not the prototype was not yet finished. Maybe in future we will see some improvements in this area. I have strong feeling that it can be much better in the future. But in general, definitely, if you are thinking about this area, try to reach at least 13 or maybe 14 in terms of Postgres major version. You will feel much better. Because in terms of visibility, in terms of how B-tree indexes behave and so on. Okay, anything else related to hot updates?
I think it's quite important to recap. So the two big things needed to achieve a hot update are: one, enough space on the page, and two, no index columns being updated. And that kind of leads developers to two things you can do about this. One is make sure there's more space available on each page. So that's where fill factor tuning can be looked into. And then second one is make sure no index. So we've covered the kind of make sure your indexes, you don't have indexes on columns you want to update if you don't need them. So if you've got any unused indexes, it's a real benefit for cleaning those up. Or if there's a trade-off there to consider, if you've got a very high write heavy workload, maybe you're okay with some reads being a bit slower as a result. So there's that natural trade-off there. But the one we haven't talked about much is that fill factor tuning. And something I didn't know until today when I was reading up on it is that if you reduce the fill factor, if you have a partition table, it's quite nice. You can experiment on fill factor of new partitions.
Right.
Not in production maybe, but the other point that I learned today, though, was that if you change the fill factor on a table, you can change the fill factor on an existing table without rewriting it all. It doesn't change your past data, but you can benefit going forwards at least, which is something that's quite interesting as something you might actually be able to do. You don't have to do a full table rewrite or similar to start getting the benefits going forwards.
Right. So again, fill factor is the threshold when defining when new page should be allocated and used when new tuples are coming during inserts or updates, right? And for table, it's 100 by default. For indexes, it's 90 by default. Meaning for indexes, we are better prepared for new pages use. I mean, to avoid them actually, right? To make them less likely to happen. But the question is, should we decrease fill factor for tables from 100 to 90 or 80, 70, 60, 50 maybe? I saw 50. Some people use 50.
Oh wow!
Yeah. Answer is test always.
Yeah.
Right? There is no magic answer here. And it will depend on data and especially on workload and also on your activity of AutoVacuum. If you have not tuned AutoVacuum, you will not benefit a lot. So AutoVacuum will need to clean up very quickly.
That's such a great point. And things that prevent cleanup are also problematic here. So for example, if you have long-running transactions that prevent things being marked as dead. So there's a whole interplay in terms of system level things to consider. Testing, I think, on something as realistic as possible is quite important here. So your pages need to be filled with data that's roughly realistic in order to determine whether there'll be space available.
Or if you have a long transaction on a physical standby with hot standby feedback on, or if you have a logical standby which is lagging a lot, your AutoVacuum will not do your proper work, and this is an issue. And in this case, fill factor won't save you. Actually, a fill factor even will make things worse because more pages. Fill factor, if you reduce it, you will need more space to store the same data, right? If you set 50
initially, yes,
to twice more. Initially, right. So experiments, like I saw a blog post from Cybertech, which for some synthetic benchmark workload showed that if you decrease fill factor from 100 to 90, roughly you have performance improvement for updates also like roughly 10%, roughly. But further, it's not so. If you in next 10% don't give you 10% of performance improvement, only like a couple of percent. So maybe like the conclusion is maybe you should have 90 for tables as well, right?
Oh, you mean by default? Well, yeah.
Well, by
as you
default
said,
in your application, but we cannot say it's the rule for everyone. It should
Well,
be tested.
if you have append only, like if you have an append only workload, or if you have append only tables, there's no point reducing it as far as I can tell. So we're only worried about update heavy tables.
If append only means no inserts, no updates, no deletes, then yes.
Yeah, exactly.
Right.
Yes.
Only inserts. Like
yes,
a
exactly.
log-like table,
Exactly.
which definitely should be partitioned. And only one or two indexes maximum should be used on it. Okay. Because inserts also modify indexes. There are no hot inserts, unfortunately, right? Insert always modify all indexes, unfortunately. So if you want very good performance for insert, you need to have fewer indexes, as few as possible.
Interesting,
right?
Yeah.
Right?
Yeah. I hadn't thought
Delete
about
is
that.
the same. Delete also modify all indexes. There is no hard delete. I'm just like raising silly questions. Do we have hard delete? Answer is no. Right? No, we don't have it. So delete will modify all.
Interesting.
Both inserts and deletes they will write to wall a lot because they need to implicitly they will modify all indexes you have on table. So append only case usually, like I see people prefer not having indexes at all, but maybe it's not a good idea as well because like who will take care of duplicates, for example, right?
Yeah.
But maybe it doesn't matter a lot, but still.
Yeah,
Sometimes
primary
people,
key feels important. Anyway, I think
yeah,
we've covered that quite well. I think I'm looking back over the question, we've covered fill factor, hot updates, kind of workloads, performance, when it's worth customizing, and the age-old advice to
how
test
to
it.
control registered user tables.
Yeah, exactly. How to monitor, how to look.
Don't forget about buffers, right?
Yep.
Buffers.
It's like
buffers. YouTube viewers should see buffers.
Yeah. Nikolai has a T-shirt on for anybody listening with explain, analyze, and then buffers in bold, which is awesome. Feels like a bit of a wrap-up episode from all of our previous ones, or kind of a best of.
Oh, I'm sure it won't be a wrap-up because buffers are everywhere, actually. If you work with Postgres, you should think about I/O in the first place. So that's why buffers.
No, I meant like a highlights, best of from our previous episodes. Yeah. Awesome. Well, thanks everybody. Keep the suggestions coming. I don't think we'd have done this topic so early if we hadn't had it requested. So that's great. Thank you, Nikolai.
Definitely, I would I would be happy to hear about some real life stories, production stories related to fill factor and hot updates. It's always interesting because we have some materials, but most of them are talking about some synthetic, like experimental environment, not about real production. And the production stories are always interesting to hear because they tend to be reproduced in other places.
In fact, in case interesting, Adyen shared that they changed their fill factor to 85%, which is super interesting.
Interesting, yeah.
Again, it'd be great to hear what numbers other people have settled on based on their own testing.
Yep. Good.
Wonderful. Well, thanks again, everybody, and see you next week.
Oh, it was episode number 20, right?
Yeah.
Yeah. Okay. Almost half a year without interruptions, without breaks. Good. Thank you, everyone, for being with us.
Absolutely.
Till next week.
Bye.